Yes, good afternoon, dear students. Again, I'm explaining some of the clarification I need to give for this example 8.4. It is in page number 538. So, after you are converting into sinusoidal form and avoiding j in the numerator, and you are making it as a real term and imaginary term. So here, as you can see that here there is an omega. That omega you can keep it here. Okay, there is a minus. That minus you can keep it here. Okay, so instead of keeping minus down, you can keep minus above. So here, when I explained about when omega is equal to minus infinity, I want to give this only one. Then I am going to the next problem. Here you got it as minus 0 minus j0. So this minus sign we are taken to the up. So here there is, I'm putting as a plus. Minus sign is, I kept it above. So here, when omega is equal to minus infinity, so this you go through it and try to understand. This is applicable. Next we are applying omega is equal to 0 minus, then 0 plus, then plus infinity. I'll explain out minus infinity what happened. So here we are putting omega square minus infinity square means it is infinity square only. So here 21 infinity square, here infinity square, here 1 plus infinity square, here 1 plus 9 infinity square. So 1 plus some infinity square, it is infinity square only. Here 1 plus infinity square, this is also 1 infinity square, this is also infinity square. So what you can see, this infinity square and this infinity square, we can cancel it. So ultimately here infinity square, so infinity raised to 4. 1 divided by infinity raised to 4, certainly it is 0 with a minus n. This is plus. Here I am putting it as here plus, here it is minus. So here as you can see that here 1 divided by infinity raised to 4, it is with a minus sign, so it is we are getting minus 0. So in a hurry, last class and on the last video, it may be confused. That is, I am repeating once more. So I cannot, because of some mistakes in some video, I cannot completely delete it because uploading all those mistakes around 2 to 3 hours. So time is very precious. That is why. So that corrections I am giving now. Now the second part. Here 2 minus 18 omega square. Omega square we should connect minus infinity. Minus infinity square means it is plus infinity square. 2 minus 18 infinity square. So 18 infinity square we can say infinity square. So 2 minus infinity square, it is nothing but minus infinity square only. And here, so here as you can see that minus and this minus can be cancelled. So you are getting plus. But here in the denominator there is omega, that is minus infinity. 1 plus minus infinity square, it is infinity square plus 1, it is infinity square. Here also 1 plus 9 minus infinity square, it is again equal to infinity square only. But here as you can see that minus and minus cancel. So here infinity square and here infinity square is there. So that is cancelled. So here you can see minus infinity into infinity square. So denominator you will get this already become plus. So 1 divided by minus infinity raised to cube, that is again 0 only, but denominator minus sign is there. That is why it is equal to minus j0, because here this minus sign and this minus is cancelled, but here there is a minus sign, so Net effect, this will become minus J0. Other thing is, I think that completed. All this drawing, everything I already explained. So we will move to the next problem. Sketch the Nyquist plot and comment on the stability of the closed loop system whose open loop transfer function is g of s into h of s k into s plus 3 divided by s into s minus 1. So here, when you are observing it, the transfer functions, there is a 0 and there are 2 poles. So when you are observing it, you can see that s plus 3. So s is equal to minus 3. So it is in the left half of s plane. So the 0 is at left half of s plane. Next, s is equal to 0. So you can see a pole at the origin. Another is s minus 1 is equal to s is equal to plus 1. So you are having a pole at the right half of s plane. So here, as you can see that when you are analyzing it, you can see that there are one pole to the right of right half of s plane. So here there is no zeros on the right half of s plane. One pole at origin, another pole is at right half of s plane. So here P is equal to 1. So in order to be a stable system, what we can see that the Nyquist plot should be a counterclockwise contour that should encircle minus 1 plus J0. Then you can say that the system is stable. Okay, the system is stable. Now, there is a value of k. With that also we need to consider. So, given open loop transfer function has one pole in the right half of the s plane. So, P is equal to 1. For the closed loop system to be stable, the Nyquist plot must encircle the minus 1 plus J0 point of the QoS plane once in the counterclockwise directions. That's exactly what I told. G of s, h of s has one pole at the origin. There is a pole at the origin. So you should bypass that. The Nyquist contour is therefore intended to bypass the origin. So here, now we have to convert this into sinusoidal form. This we need to convert into sinusoidal form. So you will get it as Gj omega Hj omega is equal to Kj omega plus 3 J omega into J omega minus 1. So in order to make a real and imaginary part, so we should multiply the complex conjugate of J omega minus 1. That means J omega plus 1 to the numerator and denominator. So when you are doing like that, you can see that minus, yes. So here we will take in the form of 3 plus J omega. Then in order to take 1 minus J omega, you should take a minus sign outside. So minus J omega into 1 minus J omega. And the complex conjugate of 1 minus J omega, you will take it as 1 plus J omega. That should be multiplied. So when you are multiplying the numerator term, you will get k into 3 minus omega square plus 4j omega. When you are multiplying these two terms, you will get 3 minus omega square k into 3 minus omega square plus j4 omega. Denominator, when you are observing it, you can see that minus j omega into 1 plus omega square. Now when you are dividing this, you can put it as here k into j4 omega Here j omega is there. That 2 can be cancelled. So we are getting it as, and minus sign is there. So minus 4k divided by 1 plus omega square. When you are dividing this by this minus j, you can take it to the top. So it will become plus j k 3 minus omega square divided by omega into 1 plus omega square. So you got the real term and imaginary term. So students, you should try to concentrate how to get this. Normally, the denominator term, that is in 1 plus j omega or 1 minus j omega term, whose complex conjugate should be multiplied to the denominator as well as numerator. If there are two terms like this, then two corresponding complex conjugate you should multiply to the numerator and denominator. So you are getting the term like this. Now next, as you can see that this will be your Nyquist contour. So and this will be the Nyquist plot. Nyquist contour is in S-plane. So it is sigma plus j omega. This already I explained. So the contour starts from, there are two parts in the contour. One is C1 and C2. C1 is starting from j is equal to minus infinity to j is equal to 0 minus, then 0 plus, then plus infinity. Since there is one pole, so you should bypass that. So the contour will come here and it will bypass that pole and it will go to plus infinity, j is equal to plus infinity. So this is the C1 part of the contour. C2 is an arc whose can be represented by r into e to the power of j pi, where r is the radius, r tending to infinity, and pi varies from plus 90, 0, minus 90. What about this bypassing portions? This bypassing portions is represented by epsilon e to the power of j theta, and theta varies from, this side is minus 90, 0, plus 90, and theta, epsilon tending to 0. So this contour is almost common. If there is a pole at the origin, you should bypass. If there is a pole on the imaginary axis, that pole should be bypassed. So as already we aware that that is nothing but a singular point. This is a singular point. You should avoid the singular points. So pole is a singular point. That is why we are avoiding that. Okay. So now for C1, for C1, we need to calculate the corresponding mapping. C1, we have to corresponding mapping in corresponding mapping in the Nyquist plot. For that, we need to find the points at omega is equal to minus infinity. So you should substitute minus infinity here. So here minus sign is the 4k 1 plus minus infinity square. Minus infinity square means it is infinity square. 1 plus infinity square, it become infinity square. So minus some term divided by infinity square, it will become minus 0. Then what happened to this term? If you are putting infinity minus infinity, omega is minus infinity. So here plus sign is there and omega is minus infinity. Here 3 minus omega square. So omega square become minus infinity square become plus infinity square. So here there is a minus sign. 3 minus infinity square, it is minus infinity square only. So here you will get a minus infinity k into So here k into minus infinity square divided by omega is minus infinity, so minus omega, so that above there is a minus sign, k into minus infinity square, and here minus infinity, that minus minus will cancel. So here it is k into infinity square, here infinity 1 plus infinity square, that is infinity square, so infinity square will cancel. So k divided by infinity with the plus sign, so I am getting it as plus j0. It's not very tough to understand, so please try to go through it. Now when at omega is equal to 0 minus, what happened? At omega is equal to 0 minus, so when you are getting omega as minus 0 minus, so omega square become minus 0 whole square become plus 0 square only. So 1 plus 0 square it become 1. So here there is a minus sign is there, minus 4k, minus 4k. What about the imaginary term? Plus jk 3 minus omega square. Omega square means 0 minus square, that is 0 square. 3 minus 0, that is 3 only. So 3k divided by here 1 plus omega square, that is omega square again 0 only. 0 square, 0 minus square means 0 square only. 1 plus 0 square means 1. But here omega is there, that is minus 0. So plus j some term divided by minus 0, so it become minus j. Term divided by 0 means minus j infinity. Now when omega is equal to plus 0, what happened? When you are substituting omega is equal to plus 0, this become again 1 plus 0 square. So this is become minus 4k plus, no, you have to see the imaginary term, 3 minus 0 square, 3 only. Here, yeah, 1 plus omega square, 1 plus 0 square, that is 1 only. But here 0 plus positive 0. So some term divided by 0, that is plus infinity with the j. So j plus infinity. Now when you are substituting omega is equal to plus infinity, what happened? When you are substituting omega is equal to plus infinity, so minus 4k divided by 1 plus omega square, this become an infinity square, some term divided by infinity square with a minus sign, so minus, it becomes 0. What happened here? Here it is plus j, okay, 3 minus omega square, 3 minus omega square, omega is equal to infinity, so it become minus 3 minus omega square. 3 minus infinity square is minus infinity square. Minus infinity square into k, it is also minus infinity square divided by plus infinity into 1 plus infinity square, so it is infinity square. So this infinity square and this infinity square will cancel, but there is a minus sign, minus k divided by infinity, so it becomes minus j0. So you got the term when it is approximate plot when you are drawing it. Okay, when you are drawing the approximate plot, so here as you can see, when omega is equal to minus infinity, g j omega h j omega is equal to minus 0 plus j0, and omega is equal to 0 minus g j omega h j omega is equal to minus 4k minus j infinity. Then when omega is equal to 0 plus, this will become minus 4k plus j infinity. At omega is equal to infinity plus, then this will become minus 0 minus j 0. So when you are plotting into UV QS plane, so this is U J V. When omega is equal to minus infinity, we are start from omega is equal to minus infinity, you are getting it minus 0 plus j0. Minus 0 means this side, real part is minus 0 plus j is somewhere just above this point, this side. And when omega is equal to 0 plus, g j omega h omega is equal to minus 4k. Minus 4k. Minus 4k means it is in the left half of real axis. Minus j infinity. So minus j infinity. So this side somewhere 4k minus j infinity. So suppose if we are putting this as minus j infinity. So here it is plus j infinity. So suppose if we are putting this as 4k minus 4k. So this point is 1. So you should draw a contour in such a way that it should come like this and it should touch like this. Now after that we will see about 0 plus. 0 plus is 0 minus to 0 plus, we will do it. That we have to analyze the other term, that is epsilon e j theta, we have to analyze it. Then only we can draw it. Now when omega is equal to 0 plus, you are in minus 4k plus j0 here. Okay, minus 4k plus j infinity. And at infinity plus, you will get a minus 0 plus, minus 0 means this side, minus j0 means slightly this, so you are getting a point like this, exactly 0 only, but the point is just like this. So we have to draw a contour from here, so that is coming like this. Okay, something like this. Again there are some variations. So like this point. Now this is about a 0. Yes, this is about a 0 minus. This is about a 0 plus. So 0 minus and 0 plus connection, you should get it. For that we should analyze we should set S as S is equal to epsilon e to the power of j theta. So when you are substituting in your expression, these expressions, okay, limit of epsilon tending to 0, k into epsilon e to the power of j theta plus 3 divided by e to the power of e to the a j theta into epsilon e to the power of j theta minus 1. So here as epsilon tending to 0, what happened here is this become 3, this becomes 0, epsilon becomes 0, and this also becomes 0. 0 minus 1, so here minus 1, here plus 3, 3k minus, this is 0 minus 1, so minus 1, so this is minus 3k divided by 3 epsilon e to the power of j theta. Again limit epsilon tending to 0. Now 3k divided by epsilon tending to 0, some term divided by 0, that means it is infinity. Yeah, so here I'll limit epsilon tending to 0, so you are getting minus 3k divided by epsilon e to the power of j theta. So you are getting minus sign as it is, some term divided by epsilon, that is equal to infinity minus infinity e to the power of this you are taking on the above side, so it is minus j theta. So minus infinity into e to the power of j theta, that you can say as plus infinity. This is equal to plus infinity, where angle you should add 180 degree. Okay, so at the angle you should add 180 degree. Okay, this minus sign you can put it plus e to the power of minus j theta. Here infinity become plus infinity, so it is equal to plus 180 degree. So you know that where infinity is, yes, suppose in a graph this side is minus infinity, this side is plus infinity. So if you want to plus infinity, you should add 180 degree. Okay, this is 180 degree. The same way you can understand that here it is. So from here to here, from here to here, the degree is 180 degree. So that is why when you are making this minus infinity to the power of j theta to plus infinity, if you want to make, you have to add 180 degree to that. Now theta varies from minus 90 to 0, then plus 90. So when you are adding 180 degree minus 90, so you are getting minus 90 degree. So 180 degree plus 180 degree, theta is minus 90, so it is 90 degree. Outside there is a minus sign, so it is minus 90 degree. Then theta is equal to 0, you are getting minus 180 degree. When theta is minus 90, so now plus 90, 90 plus 180, 270, outside is minus, so it will become 270. So the magnitude is infinity. Magnitude is infinity from where? Minus 90 to minus 180 to minus 270. Okay, so when you are taking an example here, minus 90 means from here it starts, minus 90 means this, to it will go to minus 1, from here to, I will draw dotted line, infinity this is, minus 180, then minus 270. So this is minus 270. If you are taking in this direction, this is minus 270. So till here it is infinity. So you have to take the intersection of these two. So only from here to here you will get the graph. Intersection of this and this. So you are getting a graph like this, because even though it starts from minus 90 to minus 270, but this graph is from here to here. So you should get a connection from 0 minus to 0 plus. So the graph is approximately like this. Then what out? Now you have to see the effect of C2, how it is C2. So in order to, for that, you have to substitute S is equal to R into e to the power of j pi, R tending to infinity, pi varies from plus 90 to minus 90. This two variation you should very carefully understand. So, and the angle, the direction, here we started, from here we started first from here to here. So you are getting, first we started from here to here. So the angle is like this, Now after that, from 0 plus to this is infinity plus, so the direction is like this and like this. Then here it varies from minus 90 to 180 to plus 90, so the angle direction is like this. Okay, so you can see here like this. So omega is equal to plus infinity here. Omega is minus. You are starting from minus infinity to 0 minus. So it will like this. Then 0 plus to plus infinity. So in this directions. Apart from that, from this contour, you got from minus 90 to minus 270 an arc like this with the infinity radius, but intersection of these two only from here to here. Then what about here? Effect of this C2. You see that for that you have to substitute S is R into e to the power of j pi, where R tending to infinity, pi varying from plus 90 degree through minus 90 degree. So here limit of R tending to infinity, you have to substitute in your expression here S as R into e to the power of j pi. So k into R into e to the power of j pi plus 3 divided by R into e to the power of j pi into R into e to the power of j pi minus 1. That is equal to limit of R tending to infinity. So here what happened is, when R tending to infinity, this will become infinity. This also become infinity. So infinity and infinity will cancel. So only you can see that this and this will be remain. So k divided by R into e to the power of minus j infinity j pi. This e to the power of j, if you are taking, it is e to the power of minus j pi. K by R, again R tending to infinity. So some term divided by infinity is 0 into e to the power of j pi. So the value is 0. So there is we need not to worry about. But from where to where? So pi you should substitute as plus 90. So it is equal to, here there is a minus 1. So it is minus 90. Then when pi is 0 to plus 90. So the angle is, yeah. So from minus 90 to 0 to plus 90, the magnitude is 0 only. So there is no need of representing that. Now, next, the point of intersection of the Nyquist plot with the real axis. There is an intersection here. You know that. The point of intersection with the real axis is obtained by equating the imaginary part of g j omega h j omega is equal to 0. So this is the imaginary part. This you have to equate to 0. When you are equating to 0, this is k into 3 minus omega square divided by 1 plus omega into 1 plus omega square is equal to 0. K cannot be 0. So omega square is equal to 3. 3 by omega square is equal to 0. So omega square is equal to 3. Omega is equal to plus or minus 3. So this omega you have to substitute in the real part. So real part is 4k minus 4k divided by 1 plus omega square minus 4k divided by 1 plus omega square, where you should substitute omega square, that is equal to plus or minus root 3. Root 3 square is 3. 1 plus 3. So you are getting 4. 4 will cancel. So you are getting minus k. So you are getting, yeah. So this value is minus k. Based on the above approximation, the approximate Nyquist plot is, this is a Nyquist plot. Now calculation of stability. If k is greater than 1, then certainly if k is greater than 1, then you can see that certainly there is k is greater than 1. The magnitude of k is greater than 1. Certainly the k is after this point. So certainly there is a contour encirclement about minus 1 plus j0. Minus 1 is the point once in the counterclockwise direction, that is n is equal to 1. The open loop transfer function has p is equal to 1. Here n is equal to p minus z, 1 minus 1 minus z, so z is equal to 0. So thus the system is stable. So here after this you have to again analyze it. N is equal to p minus z, p is equal to 1, we got it. Here 1 encirclement, so n is equal to 1 counterclockwise, 1 is equal to 1 minus z, so z is equal to 0. So if there is a 1 encirclement, you can see that the system is stable. So if for k is less than 1, if k is less than 1, so the encirclement is before this minus 1 plus j0. So here you are getting minus k. So k less than 1, we can see that minus 1 plus j0 point will be beyond the minus k, the crossing point to the plot. So you can see that minus 1 plus j0 point will lie beyond the minus k, beyond minus k. So k will be here, this will be here, like that. Yes, k will be beyond the point, lie beyond the point. So Nyquist spot encircle minus 1 plus j0 point once in the clockwise directions. So now if you are shifting, this encirclement will come. Yeah, so suppose when you are drawing in another way, so k is less than 1, so here k, so this encirclement is like this, another encirclement is like this, and here minus 1 0, j0 minus 1 plus j0, and you can see that here the arrow is like this. So then you can see that